I'm going to talk about the helium-3 polarization measurement today. First, for the helium-3 analyzer, it can be a good neutron spin filter because the process I listed on my slide. A neutron and a helium-3 atom can transform to a helium-4 atom, and this helium-4 state will not stay for a long while, and it will transform to the hydrogen-3 atom and a proton. For this process is spin dependent. For the spin parallel particles, the cross section is about to be 0, and for the spin antiparallel particle, the cross section is linearly dependent with wavelength. So we can see from the graph on the right that if we let the unpolarized neutrons go through the polarized helium-3, then almost all the neutrons left are have a same spin direction. So that's make the neutrons polarized. Then there are two main advantages for helium-3 analyzer. First one is that it can accept more scattered neutrons because the process I listed in the first slide is not dependent on the scatter angle or energy or momentum or any other physics values. So almost all the scattered neutrons can be accepted. And also, it's a very good uniform analyzing. It has a very good uniform analyzing power, which defined as the transmission for parallel particles minus the transmission for antiparallel particles over the sum of them. And here's a plot for the analyzing power on the right. We can see from this plot that with the increase of the wavelength, the analyzing power increased quickly and achieved to 1 finally. And this plot was made with the helium-3, which has polarization of 70%. For the next slide, the n plus means the number for particles that don't have the spin flipped, which we can see from the formula that it equals to the transmission for parallel particles plus the number of parallel particles plus the transmission for antiparallel particles times the antiparallel particle, and the flipped number of flipped particles is marked as n minus, which we switch the transmission from parallel to antiparallel in the n plus. And the polarization for neutron beam we measured is defined as the n plus minus n minus over the sum of n plus and n minus, which after the calculation equals to the analyzing power times the real polarization. Then, for unpolarized neutron beam case, we can see that if we mark the transmission for spin parallel as T plus, it's equal to e to the negative NL sigma lambda plus NL P3 sigma lambda, where the sigma is cross-section and P3 is a polarization for helium-3. And for parallel situation, for anti-parallel situation, we only need to change the sign before NL P3 sigma lambda from plus to minus. And if we have unpolarized helium-3 analyzer, then the transmission we got is marked as T0, which equals to T plus plus T minus over 2, and this equals to T to the negative NL sigma 0 lambda. And for a polarized helium-3, we mark the transmissions at T3, which equals to the sum of T plus and T minus over 2. And this equals to T0 times cosine H NL P3 sigma 0 lambda. For polarized neutron beam case, the n plus equals to 1 plus Pn over 2 times n0, and n minus equals to 1 minus Pn over 2 times n0. In this situation, for unpolarized helium-3 cell, we can define T0 equals to the transmission for parallel situation times the parallel particles plus the transmission for antiparallel situation times antiparallel particles over the total particles, which equals to e to the negative NL sigma 0 lambda. And for a polarized helium-3 cell, we can mark the transmission as T3 plus, which equals to, after calculation, is equal to T0 times cosine H NL sigma 0 lambda plus Pn times sine H NL sigma 0 lambda. So after the above calculation, we can get P3 from T3 plus over T0, which equals to cosine H NL sigma 0 lambda plus Pn, which dependent on lambda, times sine H NL sigma lambda. And if we can know Pn, the polarization for neutron beam by the measurement from like a supermicro analyzer, for example, if we know that it's 1, then T3 minus over T0 equals to e to the NLP3 sigma 0 lambda. But for unknown polarization, if we don't know the polarization for neutron beam, we can flip neutron spin to depolarize the neutron beam and measure the transmission. So the transmission we define for this situation is T3 plus the T3 minus over 2, and this equals to T0 cosine H NL sigma 0 lambda times P3. And in this situation, the polarization for neutron beam is the average polarization for neutron beam is 0. The T3 minus and the T3 plus is defined in the similar situation with TR plus and TR minus I showed in the former slides. So here's my summary. The polarized neutron beam can be used to measure NL sigma 0 of unpolarized helium-3, and we can measure the helium-3 polarization by depolarizing the polarized neutron beam by a spin flipper. Okay, so that's a brief introduction of the Helium-3 analyzer. Thank you. Thank you for your time.